here are two examples of finding the area region bounded by some graphs. They're similar but slightly different. Well, actually very kind of different. So here we have the area of the region bounded by y equals x squared plus 2, y equals 14 minus x, and x equals 0, which is the y-axis. So I was going to draw this, and I do think it's worth drawing it. Y equals x squared plus 2, I know is a parabola that does something like this. And y equals 14 minus x is a straight line that goes down from left to right with the y-intercept of 14 and x-intercept of 14. So it looks something like this. So we're looking for the region bounded by, so I should have said the region bounded by these curves in quadrant 1. So not super specific, right? Then we get this other intersection over here and we might need this side over here. So I'm talking about this region here. So in this case, I can see that I really need to find this point of intersection here. So I'm going to set x squared plus 2 equal to 14 minus x. And bring everything to the left and get x squared plus x. 2 minus 14 is negative 12 equal to 0. So I get x plus 4 times x minus 3 equal to 0. So I get x equal to negative 4 and x equal to 3. This is going to be the point where x is 3. It's going to be 3 comma 9 plus 2 is 11, or 14 minus 3 is 11. The other point x equal to 4 would be over here, which I don't care about. So to find this area, it's going to be the integral from x equals 0 to, right, I'm thinking about using vertical strips, from x equals 0 to x equals 3, of the top function, which is clearly the linear function, minus the bottom function, which is clearly x squared plus 2. Now if I hadn't actually graphed it, I would have known the top was the top by plugging in a point between 0 and 3, like 1. If I plug in 1, 1 squared plus 2 is 3, 14 minus 1 is 13, and 13 is clearly larger, so that's the larger function. Then the rest is just terrible math. I would combine this a little bit and I would write this as negative x squared minus x plus 12. And then I would integrate. I would get negative x cubed over 3 minus x squared over 2 plus 12x from 0 to 3. I plug in 3, and let's just do the math real quick. So 3 cubed is 27 over 3 is 9, so I get negative 9 minus 3 squared is 9 over 2, so that's minus 9 over 2, and then plus 12 times 3 is 36, minus plug in 0, these are all zeros. So you have 36, so let's just make everything over 2. So you have negative 18 over 2, minus 9 over 2 plus 72 over 2. 72 minus 18 is 54, minus 9 is 45. So you get 45 over 2, or 22.5 if you prefer. On the other side, we have almost the same question, but it's going to be slightly different. It's going to make a big difference. So now about the area of the region bounded by y equals x squared plus 2, y equals 14 minus x, x equals 0, and y equals 0. And so the difference here is that now if I draw this picture like this, right, and let's pretend like we've got the part over here too, right, it's not going to be this region here, it's going to be this region here, because this is the region that has y equals 14 minus x, y equals x squared plus 2, y equals 0, and x equals 0, all as boundaries. And the thing that's going to suck about this problem is we're actually going to have to break it up into two integrals. So we're going to have to do the integral, right, and we know this point was 3 comma 11. We're going to have to do the integral from 0 to 3. Right, so this area here, this 0 here. So this area here is going to be the integral from 0 to 3 of this function, which is this parabola function, x squared plus 2, minus 0, because that's the bottom function. And then for this region here, we have to do the integral from 3 to, this point here would be 14, of this function, which is 14 minus x. I will point out that this is just a triangle, and you can totally find the area by doing 1/2 base times height, where the base is 11, the height is 11, so you can do 1/2 of 121, which is going to be 60.5. We'll also see that from here. It's probably actually nicer that way though. So to do this, let's see, so let's go up here. So integrating this, I get x cubed over 3 plus 2x from 0 to 3. Integrating this, I get 14x minus x squared over 2 from 3 to 14. Not terrible, but just not quite as nice. So yeah, when you have different functions kind of as your top function, you have to break it up. So this is going to be, let's see, 27 over 3 is 9. 2 times 3 is 6. Minus 0 plus 0 is 0. I need to write that whatever. Same deal here. Well, not the same deal, actually. You have to be a little more careful here. Plugging 14, you're going to get 14 times 14, which is 14 squared, minus 14 squared over 2, minus 14 times 3, which is 42, minus 3 squared over 2, which is 9 over 2. Okay, so this is going to look like 15 plus, okay, 14 squared is 196, minus 196 over 2. 196 over 2 is half of 96, which is 98. 196 minus 98 is 98. So when you have something minus half of that same something, you just get half of that same something. So that's just going to be 98. And then this is going to be 42 minus 9 halves. That's 84 halves minus 9 halves, which is some number. 84 minus, right? This would have been way better to do as a triangle, by the way. 84 halves minus 9 halves is 75 halves. Yeah, terrible. So anyway, we get why am I using fractions? I feel like this should be a minus 75 halves. Yeah, it's good call, James. So I get 15 plus 75 halves is 37.5. So I end up with 98 minus 37.5, which is 60.5. Right, 98 minus 37 is 61, and then minus a half is 0.5. By the way, that's exactly half of 121, like we said it would be. So again, you see a triangle, you can just use the triangle formula. And then adding these together, we get 75.5. Or if you prefer fractions, that's 151 over 2. So slightly different, but actually very different.